How diesel fuel is injected into the cylinder is discussed in this video. The diesel fuel injection system is the most complicated and crucial component in working the CI engine. The engine performance, power OP, economy, etc. greatly depend on the fuel injection system's effectiveness. Diesel fuel injection system. The fuel system of a diesel engine consists of many components. The main difference between the fuel system of a diesel engine and that of a petrol engine is that the fuel system of a diesel engine consists of an injector, instead of a carburetor, the remaining items being the same. In a diesel engine, only the air is sucked and compressed inside the cylinder. At the end of the compression stroke, the diesel fuel is injected by an injector in the compressed air, which ignites due to the heat of compression and gives a power pulse to the piston. The fuel pump delivers fuel at comparatively low pressure to the injector. Every cylinder is fitted with an injector. The quantity of fuel to be injected is controlled by the injector. If less fuel is injected, less power will be developed and the engine will run slowly. With the effective compression ratio of 14:1, the initial temperature of 60 degrees Celsius, and assuming true adiabatic compression, the resulting temperature at TDC would be 675 degrees Celsius. These conditions would be approximately attained at fuel load and full speed. This temperature of 675 degrees Celsius is more than sufficient to ignite diesel fuels, which have self-ignition temperatures in the air at atmospheric pressure ranging from 350 degrees Celsius to 450 degrees Celsius. Requirements of a diesel fuel injection system. Basically, the purpose of carburation and fuel injection is the same, i.e. preparation of the combustible charge. But in the case of carburation, fuel is atomized by processes relying on the air speed greater than the fuel speed at the fuel nozzle, whereas in fuel injection the fuel speed at the point of delivery is greater than the air speed to atomize the fuel. The functional requirements of an injection system are listed below. 1. The introduction of the fuel into the combustion chamber should take place within a precisely defined period of the cycle. 2. The metering of the amount of fuel injected per cycle should be done very accurately. 3. The quantities of fuel metered should vary to meet the changing load and speed requirements. 4. The injection rate should be such that it results in the desired heat release pattern. 5. The injected fuel must be broken into very fine droplets. 6. Proper spray pattern to ensure rapid mixing of fuel and air. 7. The beginning and end of the injection should be sharp. 8. Timing the injection of the fuel correctly in the cycle so that maximum power is obtained, ensuring economy and clean burning. 9. Uniform distribution of fuel droplets throughout the combustion chamber. For accomplishing these requirements, the following functional elements are required in a fuel injection system. 1. Pumping element. To move the fuel from the fuel tank to the cylinder and piping etc. 2. Metering elements. To measure and supply the fuel at the rate demanded by load and speed. 3. Metering control. To adjust the rate of metering elements for changes in load and speed of the engine. 4. Disturbing elements. To divide the metered fuel equally among the cylinder. 5. Timing controls. To adjust the start and the stop of injection. 6. Mixing elements. To atomizes and distribute the fuel within the combustion chamber. Classification of diesel fuel injection system. Diesel fuel injection systems are used to deliver fuel to the engine's combustion chamber in a diesel engine. These systems are crucial for the engine to operate efficiently and produce the desired power output. There are several types of diesel fuel injection systems, each with unique characteristics, advantages, and disadvantages. Diesel fuel injection systems can be divided into two basic types. They are 1. Air injection system. In this method, fuel is forced into the cylinder by means of compressed air to very high pressure. The rate of fuel admission can be controlled by varying the pressure of air. The fuel is metered and pumped to the fuel valve by a camshaft-driven fuel pump. The fuel valve is opened by means of a mechanical linkage operated by the camshaft, which controls the timing of injection. The fuel valve is also connected to a high-pressure air line fed by a multi-stage compressor which supplies air at a pressure of about 60 to 70 bars. 2. Solid injection system. In this method, fuel is injected directly into the combustion chamber without primary atomization, as termed a solid injection. It is also termed a mechanical injection. Solid injection systems can be classified into four types. 1. Individual pump and injector. In this system, each cylinder is provided with one pump and one injector. Also in this system, a separate metering and compression pump is provided for each cylinder. The pump may be placed close to the cylinder as shown in Fig. A, or may be arranged in a cluster as shown in Fig. B. In a high-pressure pump, the plunger is actuated by a cam and produces the fuel pressure necessary to open the injector valve at the correct time. The amount of fuel injected depends on the effective stroke of the plunger. 2. Unit injector system. The unit injector system is one in which the pump and injector are combined in one housing. Each cylinder is provided with one of these unit injectors. Fuel is brought up to the injector by a low-pressure pump at the proper time. A rocker arm actuates the plunger and thus injects the fuel into the cylinder. 3. Common rail system. In a common rail system, a high-pressure fuel pump delivers fuel to an accumulator, whose pressure is kept constant with the help of a pressure-regulating valve. A common rail or a pipe starts from the accumulator and leads to the different distributing elements for each cylinder. Please subscribe and follow my website www.automobilehut.in. The link is in the description. For each cylinder, there is a separate metering and timing element which is connected to an automatic injector injecting fuel into the cylinder. In the common rail system, the supply pressure of the fuel is independent of speed and hence is not affected by the fuel pump. The amount of fuel entering the cylinder is regulated by varying the length of the push rod stroke. 4. Distributor system. In this system, the pump which pressurizes the fuel also meters and times it. The fuel pump, after metering the required amount of fuel, supplies it to the rotating distributor at the correct time for supply to each cylinder. The number of injection strokes per cycle for the pump is equal to the number of cylinders. Since there is only one metering element, a uniform distribution is automatically ensured. Not only that, but the cost of the fuel injection system also reduces to a value of less than 2/3 of that for individual pump systems. Conclusion. In conclusion, the diesel fuel injection system plays a crucial role in the operation of a diesel engine. Understanding the different types of diesel fuel injection systems can help engine builders and technicians choose the best system for their specific application. The choice of fuel injection system depends on factors such as engine performance requirements, fuel efficiency, emissions regulations, and maintenance costs.